So in WAN technologies, I've explained clearly about differences between leased line and broadband. So leased lines are fixed bandwidth. Fixed lines also we can say. So more secured because dedicatedly have a separate link. And there is one agreement between the user and customer and service provider. We call it is SLA, service level agreement. Like less than 1% downtime means almost no downtime, but high price. So broadband, no fixed bandwidth, shared bandwidth, less secured, more downtime, less price. So for corporate networks, for commercial networks, leased lines is recommended to use. In WAN topologies, hub and spoke topology, full mesh topology, partial mesh topologies are available. Based upon your requirement, you can use any one of the topology. WAN connectivity, like WAN connectivity are done for leased line, MUX modem, optical fiber cable, is all the equipment and devices are required. The device which generate the bandwidth, the device we call master, device which will accept the bandwidth, we call it is slave, master and slave. Technically, DCE and DTE. What is the full form of DCE and DTE?
Data communication equipment.
Okay. Data communication
Data
equipment,
termination.
data termination
Data
equipment.
termination.
Right, Ayyappa. Good. So next we discussed about when a distance between two routers is short, like to replace, to connect, we replace with all modem, MUX, optical fiber cable with one special cable called V35 back-to-back serial cable. One end is predefined. One end has to be DC, other end has to be DTE. Okay. And WAN encapsulation mechanisms. Like there are two protocols, Triple P and HDLC protocol. So what is the full form of Triple P and HDLC?
Standard protocol and Cisco proprietary protocol.
No, I'm asking
Sorry,
about standards.
high level data link.
Point PPP means?
Point to point.
Point to point protocol.
One is point-to-point protocol and high-level data link control protocol. Now, what is the difference between Triple P and HDLC?
P is open and HDLC is
Cisco proprietary.
Cisco proprietary. What
asks
is
for
open
authentication
standard?
and no authentication.
What do you mean by open standard?
It can take from both ends can be different, but on HDLC it has to be Cisco or like the same similar
Open standard
connection.
means it works in multiple vendors. So we can configure
Yeah.
that protocol in Cisco devices and non-Cisco devices also like a Juniper, Multicom, MIPO, HP. It can support for multiple vendors. Whereas whenever if we say protocol, proprietary protocol, it works in only Cisco vendor actually.
Yep.
Moreover, point-to-point protocol support for authentication and compression mechanism. Like SDLC, no support authentication and compression. And WAN interface configuration and verification also is done. I hope everyone have you practiced on 3 routers.
Yes.
Good. Yeah. All right. So today we'll continue with the scenario is this. Our target is, a main ultimate target is, this is your branch office 1, left side, branch office 1, this is branch office 2, middle one is head office. Branch office 1 LAN users, head office LAN users, branch office to LAN users should communicate. These are ultimate target, LAN to LAN communication. Like how to enable LAN, one office LAN to another office, LAN to LAN, LAN users to LAN users communication. These are target actually. Okay. So in previous class, we just discussed about how to connect a WAN link between the branch to branch and what type of technologies we have and how to connect it, how to enable connectivity, all about only WAN interface configuration. That's all. But our ultimate target is what? LAN users to LAN users communication. Example. Yep.
Excuse me, sir. Yeah, according to the last experiment that we have done, can Bangalore router communicate with Chennai router?
No, not possible.
No, right? Okay, okay.
Yeah. Because you just enable a link between Chennai to Hyderabad and Hyderabad to Bangalore. That's all. Chennai to Bangalore communication is not possible actually.
Okay. Yeah.
That is what? How to enable communication from one LAN to another LAN is today our target. For example, this is your mobile phone. So once you connect to internet, like through Wi-Fi or mobile data, you'll get one IP address, right? Because every device must require IP address. Let us say this is a mobile phone and you'll get automatic IP address 192.168.1.2. And your target is you are trying to reach one public server, which is fb.com. From your mobile phone, you have opened a web browser and I'm typing is fb.com. Can anyone tell which device is a source device and which one is a destination device?
Source is FB and destination is our mobile.
Oh my God.
No.
No.
Okay.
You said reverse actually.
No, I thought we were requesting it from FB, so that will be the source and destination.
You
It
are
has to
not
reach our
requesting
mobile.
from
So
FB, you are requesting to FB, right?
okay,
Our
okay.
mobile.
From our mobile, yeah. So first understand the source and destination. Source means what? Where a request starts is a source. So from your laptop or from your device, from your mobile phone, you are requesting to reach FB. So source is your device, correct? What do you mean by source? Where a request starts. Means if you open your FB page, fb.com is your device's source. Means from your mobile phone, data traffic is generated. Data packet is generated. Data packet, remember packet contains source IP, destination IP, source port, destination port along with your data. Is all traffic is generated. This traffic is generated from which computer? 192.168.1.2 computer. And it reaching to where? fb.com. Let's say FB is one public IP, 18.1.1.1. So traffic, IP traffic will go to FB server and FB server will reply, will come back to you. Then you can see FB page is open in your state. Agree? So to communication from one device to another device, like traffic should reach to the destination device and destination should give reply back. Then communication is enabled. So what exactly happening here? IP traffic is moving from where to where? From 192.network to 18.network. This process we called IP routing. IP routing is a process of moving IP traffic from one network to another network, one LAN to another LAN. So once traffic is moving and reply is coming back, then communication is enabled. Same like how to enable communication from your branch 1 to head office, branch 1 to branch 2, all LAN to LAN. From here also, data traffic, one of the user data traffic is generated. It is moving from branch office 1 network to head office network, or branch office 1 network to branch office 2 network, and reply should come back. So this process what we call IP routing. So IP routing is a process of moving IP packets from one network to another network. So finally, how to enable communication from one LAN to another LAN? What is your answer? What need to configure? What process we need to configure in routers? IP routing. If we configure IP routing in all three branches, then communication will be established. IP routing means what? Traffic is moving from one network to another network. So routing involves two basic activities. When traffic is moving from one network to another network, it involves two basic activities. One is it will check how many paths are available from branch 1 to head office. If it is only one path, then only one path. Or if there are the multiple paths, then routing will choose the shortest path. Oh, there are multiple paths to reach destination. It will choose a shortest path actually. And forwarding packets to this shortest path. So two activities. Routing involves two basic activities, determining the best path, forwarding packets to these best paths. Okay, guys. Today, point number 1 about IP routing. What is IP routing? Point number 2. So to implement routing on branch office and head office, we need to follow some IP conditions. Conditions for IP routing. All of you following me, guys?
Yes.
Okay. So to implement routing on these branches, first we need to follow what? IP conditions. Condition number 1. Head office router IP address should be in the same network as the head office LAN, and similarly, a branch office router fast Ethernet IP address should be belongs to same network as the branch office LAN. What is the meaning of this point? I think already we know that logic condition. Again, I'll repeat. So condition is head office router fast Ethernet IP address and head office LAN users IP address should be in same network address. Similar condition to branch 1, branch 2, branch 3, branch 4, everywhere actually. That's the condition number 1. So simply you can say router LAN interface IP address, LAN users IP address should be in same network. Now, for head office LAN interface IP is 10.0.0.1, then for all end devices, IP address should be in which network?
Same network, 10.0.0.
Same network. Say 10.0.0.0.2, 10.0.0.0.3, 10.0.0.4, like we need to. Similar condition for branches also, like branch 1, branch 2. Branch 2, 192.168.2.1, and end devices should be in same network. 2.2, 2.3, 2.4. Branch 1, 1.2, 1.3, 1.4. This is the condition number 1. Condition number 2. Serial interface IP between head office and branch office should be in the same IP network. In previous session, I clearly explained about this IP condition. Branch office 1 serial interface IP, head office serial interface IP, both should be in same network. Remember? Example, it is 172.16. 172.16.0.1. In other end should be in same network. 172.16.0.2. Similarly, 172.17.0.1, 172.17.0.2. This is condition number. Clear, guys? Yes, please.
But will that be possible to be in the same network for two branches in two different locations?
No. See, example, branch 1, if you are using 192.168.1.1, 1.0 network. This is 1.2, 1.3, 1.4, right? Similarly, in head office also if it's the same network, 192.168, 1.8, 1.9, 1.10, like this you are using. One of the device IP address is 1.8. See, second computer, second user, second computer is trying to access with this IP address in head office. What is source IP? Source IP.
192.168.1.3.
1.3 is a source IP address. Destination IP address
1.8.
1.8. Packet is generated from source. You know what your PC will check? Oh, my computer IP address is 1.3, and even my destination computer IP is also 1.8. It is the same network. So destination might be in my local LAN only. So it is going to be check in LAN where is 1.8. It is going to check the destination in local devices only. So your PC will never understand, oh, my destination is in head office. Because your destination IP address is what? Same network. Then your PC will checking in local network only. Traffic will not come to at least head office. Then no communication. If you have a same network. If it is a different network, yeah, my source IP is 1.3, destination IP is 10.2. Oh, different network means it is in different network. It will send traffic to router, and router will maintain the routing table. Based upon routing table information, will forward to head office, and you can reach. Got it?
But so we thought that the LAN addresses can be repeated, right? LAN IP addresses can be repeated, right?
So LAN IP address can be repeated means for in between what type of technologies you are using. That is the matter actually. If it
Okay.
is a VPN technologies or if it is a broadband, then LAN IP addresses can be repeated. But if
Okay.
you're using a laser lines, these conditions we need to follow actually. Got it?
Yes.
Yeah. Okay. So this is the conditions we need to follow for laser lines. For any other technologies like MPLS or broadband or VPN, then LAN IP addresses can be used same also. Okay. Condition number 3. Head office LAN and branch office LAN should be in different IP network. Let us cross check. Yeah, the same condition just now we discussed about it, right? Head office LAN, branch office LAN should be in different network. Branch 1 network is 192.168 1 dot network. Head office 10 dot network. Branch office is 2 dot network. So condition number 3 satisfied or not? As per condition number 3, head office LAN and branches LAN should be in different IP network. Condition is satisfied? Yes. Condition number 4. All interfaces of your router should be in different IP network. All interfaces of router. A LAN port, which is fast Ethernet port, and you have serial port, serial 00. Have one and more serial port, serial 0/1. Like total, how many interfaces in R1 router? 3 interfaces. So 3 interfaces IP address should be in different network. for serial 0/0, we have assigned IP address is 18.1.1.1. Then 18.network, we cannot use any one of the interface on the same router. Even if you forcefully if you try to assign 18.IP address, it will give error message. Like IP address 18.1.1.1 is overlapping with 0/0. Okay. Yeah. Serial 0/1, 19.1.1.1. Different network. So for fast Ethernet, can I assign 18.network IP address? No, the network is already used. For fast Ethernet, can you use 19.network? No, even the network is also used actually. So 192.168 1. So this is the condition number 4. All interface of router should be in different network. Okay. So these conditions we need to follow to implement IP routing. Any doubts in 4 conditions?
So these all are the serial interface IP and fast Ethernet IP, but router having its own IP also or not?
No. Router IP don't have any separate IP addresses. LAN interface IP address is nothing but a router IP.
Okay, means with single router many IP edge.
Yes. Like it depends upon how many interface on the router. All IP address is a router IP address. So you don't have a separate IP addresses for router. Where we can assign IP address? We can assign IP address on interfaces only.
Okay.
Yeah. Okay. Next point number 3, types of routing, IP routing. So point number 1, what is IP routing? Conditions for IP routing, types of IP routing. Basically, we have 3 types of IP routing. Static routing, dynamic routing, default routing. 3 methods. First, tell me what is IP routing?
Process of moving traffic from one network to another network.
Correct. So moving off IP traffic from one network to another network is IP routing. That process can be done in 3 ways. Static means manually, fixed, dynamic, automatically, and default method also. There are 3 methods. Let us try to discuss about static routing now. Before getting to static routing, I would like to explain a few important points about router. Anyone remember what are the functions of router? Router functions.
Switching and packet forwarding.
Yes.
Packet switching and packet forwarding.
Packet switching, packet forwarding. Good. And
Builds the communication between two networks.
enable communication between 2 or more different networks. Good. To reach a destination, if you have a multiple paths, then what router will do?
Routing tables.
It's just
It find the shortest path, right?
Shortest path.
Yes.
Best path selection.
Best path selection. Correct. Inter-network communication, best path selection, packet switching, packet forwarding, all are router functions. But actually, how router will do this functionality? How it enables communication between 2 or more different logical networks? Like how it will find the best path, how traffic will send through best paths, and how packet switching and packet forwarding happen. This entire router mechanism, router intelligence will depends on every router maintains one table called what? Routing table. So based on routing table information only, router can enable communication between different networks. Based upon routing table information only, packet switching, packet forwarding, best path selection, entire router mechanism will be done based on what? Routing table. If router is not maintaining or if router is not enable routing table, then router is not a router, it's a dummy. Let's do the broadcast like a switch. So we want to make sure always routing should be enabled in router. Anyhow, by default routing is enabled, but if you want to disable, you can disable also. But if you disable it, then router is not a router. No mechanism, no router mechanisms. So as a network engineer, always we need to understand about routing table, what information it contains, how it is updating, whether we need to update manually or the routing will come automatically, like how it happens. Is everything we need to be understand. Good. So this is R1 routing table. R1 routing table interfaces. Fast Ethernet 0/0. Serial 0/0. Serial 0/1. So there are 3 interfaces. By default, all LAN and WAN interfaces status is what? For router LAN ports and WAN port status is
Shut down.
shutdown. Shutdown. Do you get any default IP address for interfaces? No. No IP. No IP address. No IP address. If all interfaces are down, if any one interface is not up, then your routing table, you don't see any information in the routing table actually. It will be empty because all interfaces are shut down state and IP is not assigned. Like in initial configuration, you have assigned IP address to fast Ethernet. Interface fast Ethernet 0/0 IP space address space like 10.0.0.1 you have assigned, and you have entered no shutdown command, and you got up message also. So fast Ethernet port IP is assigned and interface is activated. Then immediately your routing table will update with this network information. So on 10 dot network ID will update actually. 10.0.0.0 network ID. 10.0.0.1 is IP address. Network ID is 10.0.0.0 is C means is connected. 10 dot network is connected on which interface? FE0/0 interface. These information you can see in the routing table. So here a code is very important actually. So C means what? Directly connected. Like R will indicates RIP networks, S will indicate static network, O will indicates OSPF network, different type of codes we have. So remember, C indicates what? Directly connected network, because 10 dot network, it is directly connected to R1 router now. Yeah. Likewise, for serial 0/0, if I have assigned IP address and the port is activated, IP address is 18.1.1.1. Now tell me routing table update. You can see 18.0.0.0. It is C means directly connected to which interface? Serial 0/0 interface. Likewise, serial 0/1 interface I have assigned IP address and it is up. IP address is 19.1.1.1. Then you can see in routing table 19.0.0.0 is directly connected to serial 0/1. So basically what exactly routing table contains? Directly connected networks information you can see in routing table. Like how many active interfaces are in R1, that information you can get in routing table actually. You have 5 interfaces, out of 5, 3 are active. 3 interfaces are IP assigned and active, then you can see 3 networks only in. If 5 interfaces are assigned IP address and active, then you can see 5 networks in routing table. Got it? I'll show the practical. So here it is R1 router, show IP interface brief. Like how many interfaces are active now in R1 router? Fast Ethernet 0/0 IP unassigned status is administratively down. Fast Ethernet 0/1 same 0/
Down.
serial 0/0 0/1. Like all interfaces are what?
Down.
Down. IP is not assigned, unassigned. Now if you open the routing table, did we get any network in routing table? No. So if we use this command show IP route, so we don't have any networks in routing table. So let me assign IP address for Fast Ethernet. Interface Fast Ethernet 0/0 IP address 192.168.1.1 255.255.255.0. No shutdown. So 2 times we got up message. Interface is up, protocol is also up. Now back to privilege mode. If we check show IP interface brief, and how many interfaces are active? Only Fast Ethernet 0/0 IP assigned, status is up, protocol is up. If you open the routing table, show IP route, we can see one network is updated. 1.0/20 is directly connected. Is directly connected to which interface? Fast Ethernet 0/0. C indicates directly connected actually. One more interface. Interface serial 0/0. IP address 172.16.0.1 255.255.0.0. No shutdown. I got only one time up message, which is interface only up. Let us wait for protocol also should be up. Protocol. Yeah. Line protocol is also up. Now if we check show IP route, you can see one more network, which is 172.16.0.0 is directly connected to so on serial 0/0. It's clear everyone now?
Yes.
Yeah. So this is branch office 1 routing table. Oh. Head office routing table. Branch office 2 routing. Tell me what networks we can see in branch 1 if all interfaces are active in branch 1. Two interfaces. To interface IP is assigned and status is up. In head office route also IPs are assigned and status is up. And tell me each routing table updates. Yeah, please. First branch office 1. Start. One 192.168.1.0.
168.1.0.0. 1.0, sorry.
Is C means connected. Connected means directly connected. To which interface?
Fast Ethernet.
FE 0/0. Okay, next. 172.16.0.0
16.0.16.0.0.
16.0.0
is
serial port
also
00.
connected to serial port S0/0. Okay. Branch office 1 routing table is updated. What about head office routing? Say 10.0.0.0.0 is directly connected to which interface?
FE 0/0.
Okay. Then
172.16.0.0.
172.16.0.0
0.0.
connected to serial 0/1. 172.17.0.0 connected to serial 0/0. Next, branch 2. 192.168.2.0 directly connected to
Fast Ethernet 00.
Fast Ethernet 00. 172.17.0.0 is directly connected to
Serial port 01.
serial port 01. Clear, guys, everyone?
Yes.
Yes.
Let us check in head office routing table also. What is the command?
Show IP route.
Show IP route. Here you can see 3 directly connected networks, same like how we have updated right now. In branch office 2 routing table, which is R3, show IP route, 2 directly connected networks. Right. But our ultimate target is what? What is our main topic now?
Source to destination communication.
Now we are trying to enable communication LAN to LAN, branch office LAN, head office LAN, branch office to LAN should be communicated. So to enable communication from one LAN to LAN, what method we need to implement?
Static.
Routing, just IP routing. That method can be any method actually. So IP routing, correct? What is IP routing?
moving traffic from one network to another network.
Let us check that now. Yeah. See, one dot four user trying to connect with 10.4. I repeat, 1.4 user trying to connecting with 10.4. Tell me source and destination IP address.
This is 192.168.1.4 and destination is 10.0.10.4.
10.4.
Okay, correct. 1.4 is source IP address, destination IP address is 10.4. IP traffic is generated. The point is, this IP packet from source to destination, to reach from source to destination, this IP traffic, how many interfaces it has to be crossed? I mean, how many router interfaces it has to be crossed? Source is 1.4, destination is 10.4. In between this IP packet, how many router interfaces it has to be crossed?
Or
2, 1, 2, 3, 4.
4.
4 interfaces, right?
Yeah.
Branch office 1 fast Ethernet, branch office 1 serial, head office serial, branch head office fast Ethernet, correct? Yes. The point is this IP packet to reach the destination, in between how many interfaces? All interfaces IP network information must be available in routing table, and all interfaces status should be up, active. Then only traffic will move. In between, any one of the interface IP address is not available in routing table, or any one of the interface is down, so traffic cannot be reachable. Let us check. So here packet is generated, it will come to fast Ethernet port first. So fast Ethernet interface IP is 192.168.1.1. Do you have this information in routing table? Yes or no? 192.168.1.network IP address information, is it available in routing table or not?
Yes.
Yes, available. 1.1 is IP address, 1.0 is the network ID now. It's available. And what is the status of LAN port? It's up.
Up.
Now packet will switch to serial port. So serial interface IP address is 170.16.0.1. Do you have information in routing table?
yes.
Yes, and status is up. And packet forwarded. Then head office 172.16.0.2. Do you have information in routing table?
Yes.
Yes. Then status is up. Then packet switch to head office. And head office LAN interface 10.0.0.1. Do you have 10.0.0.1 information in routing table?
No.
Sir,
Yeah.
no.
No.
No. Then traffic is drops. Because of destination is not available in routing table. Like router don't know how to reach standard network, it is dropping the traffic actually. If traffic is being dropped, then how branch 1 LAN, head office LAN can communicate? Not possible. So this standard network means this destination network. In first case, we should know, and manually we need to update in routing table. This process we call what? Static routing. Like all destination networks, we need to update in routing table manually. So to update the destination networks, first we should know what networks are they are maintaining. Head office network is 10 dot network or 5 dot network or some other network. So that the network information you should know, and we need to update in routing table manually. So head office is 10.network. The 10.network we need to update here. 10.0.0.0. So this 10.network manually we need to update or automatically update? Manually we need to update. By using which method of routing?
Static.
Static
Static.
routing.
Then it will shows as yes. Code is yes. Means 10.network is manually statically updated. C indicates what? Oh, 170.network is already directly connected. So after updating the 10.network, now branch office 1 LAN users, head office LAN users, will they communicate?
Yes.
Aishwarya, yes or no?
Yes.
Yes. Ping google.com. This is one output. Ping 192.168.23.10. So in first case, when I ping to google.com, packet send. How many packets are sent? 4. Received 4. 0 lost. 0% loss. Means from my computer, google.com. Are communicating or not?
Communicating.
Communicating. Okay. And from my computer, I'm trying to reach to one of other destination, which is 192.168.23.10. So if you see this result, packet here also
Failed.
have sent 4. In google.com also have sent 4. But received how many? 0. 4 loss. 100% loss. Means my computer and 23.10 is communicating. Is it communicating or not?
No.
No. So when we can say is communicating,
Received should be 4.
sent 4, received also should be 4, then only communication. Now, if you update 10.network in branch office 1 routing table, then packets we can send. Can you receive from head office? Can you get reply back from head office?
No.
Then how we can say communication is enabled from branch 1 to head office? So in head office routing table also need to be update. Agree? Because head office routing table don't have this 10.90.network, then how reply will come back now? So if we use static routing method, and both things we need to update manually. In head office, what network we need to update?
168 dot
168.1.0
1.0.
is statically updated. Now branch office 1 LAN users, head office LAN users can start communication. So this is how static routing works. Okay, next example from 1.4, same computer. Now destination is 2.4. Destination is 2.4. This is a computer. Source is 1.4, destination is 2.4. So to reach from source to destination, in between how many interfaces and all interfaces IP address? Just tell me what networks we need to update in branch 1 routing table to enable communication from source to destination.
192.168.2.0.
Enough, Ravish? 2. Network is enough?
Also on the branch 2
22.17.02.
we have to update the first.
Serial interface also need to update.
Serial interface also. Yeah. Okay. So 172.17.0.0 192.168.2.0. So these networks will come in routing table automatically, or we need to update manually?
Update manually.
Update manually. By using which method of routing? Static.
Static routing.
Okay, I've updated it. Now branch 1 and branch 2, will they communicate?
Yes.
No.
No. Branch 2 also need to be updated to get the reply back, right? Then tell me what networks need to update in branch 2.
Branch 2.
172.16.0.0,
170.16.0.0,
192.168.1.0.
1.0. Branch 2 to head office, 10.0. Here also 192.168.2.0. Now all LAN to LAN communication is established actually. You can see these all red color networks we need to update manually. These all are destinations. Static network, static routes. So static routes are configured, maintained, and updated by network administrator manually. To update the days, we should know destination IP network for configuration. Administrator should know the destination network IP. Administrator distance is for static routing is 1. So what is administrator distance? In upcoming sessions, I'll try to explain about it, AD value clearly. You just remember this. For every routing protocols have a AD value. We call it is AD value. For static, AD value is 1. You just remember this value. Okay, what is AD? I'll explain it later. Any doubts? Static routing, configuration. So first you can see the syntax. IP route in global configuration mode. Destination network ID should not be IP address, it should be ID, network ID. So that is why I have updated network IDs only in routing table actually. All are network IDs, right? Yeah. So destination network ID space, destination subnet mask, exit interface type and number. This is one method. Or same IP route, destination network ID, subnet mask, next hop IP address. Any one method you can use. Let me explain about exit interface because in real time mostly use next hop. Exit interface. Say how to reach 10 dot network from branch 1. From branch office 1 router, how to reach to 10 dot network. What is the exit point? Where exactly your traffic is exiting out? From branch 1 router to reach 10 dot network, where your traffic will exit? On which interface? No. From branch 1. From branch 1 router, your traffic is
Serial
exiting
port 00.
to exit 10 dot network. To reach 10 dot network, your exit point is what? Serial 0/0. Right. Similarly, from branch 1, how to reach 192.168.2 dot network? What is exit point?
0.
Yes.
Exit point is same, sir.
Same one.
To network. Where? Branch 1 serial 00, head office serial 00.
Head office serial.
Both.
Both. Oh, okay. What is this?
Yes, the exit point will be the head office one.
Okay. So this is your home and have a different rooms. Room number 2, room number 1, room number 3, room number 4, like a kitchen, hall, like construction. Now I'm in room number 1. I'm here actually. Okay. So I want to reach to room number 2. My destination is I want to go to room number 2. Where is my exit point? Yes.
Room number 1 door is your exit.
Number
Room
one.
number 1
Yeah.
door is a exit point. Okay. I'm in room number 1 only. My destination is I need to go for room number 3. Then where is my exit point?
Same.
My destination is room number 4.
Room number 4 is okay.
Yeah, the
Yeah,
same
to
exit.
reach out
It's
to
same,
any
right?
destination, your first
Yeah.
exit point is your door, right?
Yeah.
Come back to branch 1. Yeah. Now to reach to 10 dot network from branch 1, what is the first exit point? Serial
Serial
0
port
slash
00.
So to reach out to 192.168.2 dot network from branch 1, what is your first exit point? Branch 1 serial 0 slash 0 only. So to reach to 170.17 dot network, first exit point is 0 slash 0. So to reach any destination, first exit point is 0 slash 0. Agree?
Yes.
Yeah. Now source is branch 2 LAN. You are in here, branch 2. So to reach 170.16.0.1, what is your first exit point? 0 slash 1. Exit point is this. So to reach to 192.168.1.0, 10.0. Now source is head office. You are in head office network. How to reach to branch 1? What is your exit point?
Serial port 01.
S0 slash 1. Your destination is branch 2. What is the exit point?
Serial port 00.
0 slash 0.
Yeah.
Correct? Yes. Like this we can configure actually. Yeah. So picture is completed. Now we can take a one snapshot here actually. So this will help you to reference your practices. Done? Okay. Click on R1 router. Enable show IP route. Have only 2 directly connected networks. Config terminal. IP route. Destination network 10.0.0.0. Subnet mask 255.0.0. Exit point serial 0 slash 0. So manually we are defining a route We are telling to router, you want to reach to 10 dot network, your traffic it should be exit like this. IP route 170.17.0.0 255.255.0.0. Oh, serial 0/0. IP route 192.168.2.0 255, 255, 255.0. Exit point is 0/0. This is R1. Configuration. R2. Three directly connected networks. Destinations are two networks. You can see the reference, your diagram is two networks community update 1.0, 2.0. Exit is 0/1, 0/0. IP route 192.168.1.0, 255, 255, 255.0, serial 0/1, 192.168.2.0, 255, 255, 255.0, serial 0/0. This is R2. And R3. Show IP route. Only two directly connected networks. And we need to update how many networks? Three. These three are destinations. And exit point is 0/1 only. IP route 192.168.1.0, 255, 255, 255.0, serial 0/1, 170.16.00, 255, 255.00, serial 0/1, 10 dot network, 5.0.0, serial 0/1. Done. Yeah. I'm sharing these all three routers configurations. Now if we check verification in R1 routing table, show IP route, you can see static routes also updated. But our ultimate target is what? LAN to LAN communication. R1 LAN users, head office LAN users, R3 LAN users should communicate actually. From R1 PC, check computer IPs are assigned, not assigned. Na? So 192.168.1.2, 192.168.1.2, default gateway must be assigned. Yes. So you can check communication in two methods. can see the right side, you can packets, you can take it. Keep one packet and source device and destination device. You can see the result here. Failed. One more time you can check. One more time you can check. From source to destination. Successful. Again, source to destination. Successful. Or you can ping from PC1. Command prompt ping 10.0.0.2. Sent 4, received 4, 0% loss. Clear? Any doubts? Ultimate. Finally, we have enabled communication from LAN to LAN. Any doubts, guys? Okay. So we also practice on the 3 routers. Implement static routing and send with outputs in WhatsApp. Thank you. Have a good day. And Monday, we'll continue with some dynamic routing protocol. Happy weekend.
Thank you.